Okay, this is 7.2, properties of proportions. Okay, so this is kind of things that we did for look back, and we have factoring and solve. So I'm gonna do why don't you stop the video and do these first, and then I'm gonna do all these as a demo so that the demos in this video. Okay, all right, so you assume that you stopped and you came back, and if you just want to fast forward this one, the answer is k equal 7/2. This one, you get 3m minus 4n and 3z plus c. And this one, you get minus 2a plus 5, 3a plus 5, okay? And this one, I think you have b equal wait, this is 2/3 and 3/2, I think. So if that's what you got, you can just fast forward, okay? All right, otherwise I'm gonna do a demo here. Okay, so first you want to combine so that you have a one term and one term on both sides of the equation, so you can cross multiply. So this has the same denominator, so you can combine them, and then you get k minus 6 plus 3 and k squared plus 5k plus 6 equal 1/k plus 3. It's minus, sorry, there was a minus. So it's actually 3 minus k plus 6. Okay. So if I simplify numerator, that would be 3 minus 6, so that's minus k plus 9. Okay. And then if you factor this, you are going to get 2 and 3, right? So k plus 2, k plus 3 equal 1/k plus 3. Okay, now you can cross multiply one term and then connect it with equal. You can cross multiply, so k plus 2, k plus 3 equal k plus 3 times minus k plus 9. Okay, so actually I actually didn't have to factor this one here. It doesn't. It's good to factor if there is another one over here that you can cancel, but in this case you can't cancel anything, so I will be foiling this again. So I didn't have to factor it here. Okay, so I guess you shouldn't just automatically factor. You should wait until what you're dealing with. So it's put it back to what it was before, equal, and then you have to follow this one. So minus k squared minus 3k plus 9k plus 27. Okay, so you have to simplify this now. So k squared plus k squared plus 5k plus 3k plus 6. Oh, I forgot the 9k. It was plus 9k. Well, you can simplify this to plus 6k, so then that would be minus 6k. Minus 6k, and then plus 6, and the constant is going to minus 27 equals 0. Now don't forget equals 0. I will deduct the point if you do these things and forget equals 0, or like after factoring, don't forget equals 0, otherwise you can't solve it. Okay, all right, so you get 2k squared minus k minus 21 equals 0. Okay, So now you can factor this. So you get 2k minus 7 and k plus 3 equals 0. I'm gonna erase this answer, okay? So I get more space. So then k equal 7 over 2 and minus 3. Now, I said the answer was k is 7 over 2, right? So what's wrong with minus 3? Why isn't the minus 3 an answer? You have to check in the original equation. If k is minus 3, the denominator is going to be 0. And you can't have that. So this is not the answer. And only answer is 7 over 2. Okay? All right, let's do this one. This is by grouping. These two have a 3m in them, and these two have a 4n in them. So I'm not gonna do this when I'm doing it, but for you, I'm just gonna reorder it so you see it better. You don't have to if you know what you're doing. C minus 12 and Z. I just reordered it, right? So I put this here and then put that there. So between these two, you see that there's a 3m's in there. So you factor 3m out, and what's left in this term is a 3z, right? Because 3m times 3z is 9mz. That's what this is, right? You can factor 3m out, and what's left is c. 3m times c will give you 3mc, right? And from here, same thing. You can factor negative 4n out. So negative 4n, and then this is going to be positive c, and this is plus 3z. Okay, so as you can see, the 3z plus c is in this same in the parentheses, so you can factor now these out from this. Okay, so 3m minus 4n and 3z plus c. Now, this is not equal 0. This original did not have equal 0. So this does not equal 0, and therefore we cannot solve this. Okay, it's different. This is just factoring. Okay, this one, on the other hand, has a number on the other side. So you can move this to make this a 6 and equal 0. Then you can solve this for b. That's why it says solve for b. These are only asking for factor because you can't solve it because you don't know what the other side of the equal is. Okay? All right. I'm going to erase this again. So we have space. Okay. All right. So this one, I don't like having negative in front of the leading coefficient, so I'm going to factor negative out first. Okay, now I can factor inside and then leave the negative in. You don't have to do that, but I think it's easier if you did it that way. Okay, so you have, this is 2 and 3, and this is 5 and 5. So how do we make 25 addition? Let's see. Yeah, 15 and 10 will do it, right? So minus 6a squared, it's all positive, so plus 15a plus 10a plus 25, right? So now factor by grouping, which is what we just did here. Okay, so from here and here you can take 3a out, and what's left is 2a, and what's left is 5. And from here and here you can get 5 out, right? So plus 5, and then what's left is 2a plus 5. And since these are the same, you can combine these. So minus 3a plus 5 and 2a plus 5. And you're done. Okay, again, you can't solve this because you don't know what the other side of equal is. This does not equal 0. Okay, all right, this one. 6b squared minus 13b plus 3 equals 0. So 6b squared minus 13b plus 6 equals 0. Now factor and solve. So this is 2 and 3, this is 2 and 3, and how do we, so this is negative, that means both numbers going to be negative, okay, and then add up to 13. So well, 9 and 4 would do it, right? So let's rewrite it. 6b minus 9b minus 4b plus 6 equals 0. Okay, so far so good. Now from here and here you have a 3b in there. So 3b, and what's left is 2b minus 3. And from here and here, that you only have 2, I guess, minus 2. And 2b minus 3 equals 0. So if you factor this, you get 3b minus 2, 2b minus 3 equals 0. So that means b equal to 2 over 3 and 3 over 2. Okay, and in this case, this equation can take any number for b, so both of them are answers. Okay, so answer here is this, because you're just factoring. Answer here is this, and the answer here is just this one. Okay, all right, let's go. Ooh, it took 11 minutes just to do the warm-up. All right, 2, solve for an unknown. Well, if you could do all the warm-up, you could have skipped all this, okay? Hopefully you did. An unknown term in a given proportion, and express a given proportion in an equivalent form. Okay, all right, so I think you already know all this, but just to actually, like, pretty much all this packet is a review of Algebra 1 that hopefully you already know. Well, actually, this is not even Algebra 1. This is more like, you know, fraction that you learn in elementary school and middle school, okay? You learn this in numbers, okay? So if a over b equals c over b, or a to b is c to d, is equivalent to, you can cross to multiply, so AD equal BC, or you can change this. A over C is B over D. A over C is B over D. Okay, you can do that. It's equivalent. And also B over A, you can flip the order. It's still equal. Okay, and also if these are equal, then you can add the denominator to the numerator, and the equals should still hold. Okay, and also if these proportions are all equal, meaning these are equivalent ratios, then you can add them all, and it's going to be the still ratio, the same ratio. Okay, all right, so use the proportion y over x over y equal to 5 over 2. Complete this statement. So 5y would be 2x. That's cross multiply, right? And this one you just do 5 plus 2 over 2, so that's 7 over 2. Okay, and 2 over 5 would be y over x, and this one is x over 5, so that would be y over 2. Okay, right now you are kind of a little bit confused, I think, but with the practice it will come. This is all common sense. Okay, it makes sense with the practice. Okay, all right, so let's see which one you should do. All right, so I wanted to do this for homework. Which proportion is equivalent to this? I think you can do this one. And complete the statement. I wanted to do odds here. Okay. All right, so you're doing 3, 5, and 7. And let's do 6 and 8 for video now. Okay. All right. So G over H is J over 8. So J over 8 is G over H. This was a silly one. It was a boring one, actually. All right. And these are the equivalent. So this is just applying the property, and this is N over P. You remember this is just straight as from the property from this one. Okay, that's exactly this one, right? Okay, so that's not a problem. Let's see, 9. I want to do this ABC for homework. Okay, and let's do 10. Right. Explain an easy way to show the proportion x over 7 equal to 1/3 and x over 2 is 3/7 are not equivalent. Okay. All right. So the easiest way is to cross multiply. So you get 3x equal 14. And then this was 7x equals 6. So if they are equivalent, well, but they are equivalent if you cross multiply and you get the same thing. Okay, so these are not equivalent anyway, because x is 14 over 3 and this one is x is 6 over 7, not even the same number, right? So these are not equivalent. Okay, even though there is a 2, 7 and 3 and 2, 7 and 3. Okay, so how do we make this equivalent? That's a better question. How do we make this equivalent to this? Think about it. I think I'm gonna make this homework. Think how to change this so it's equivalent. Okay. All right, 11 you can do, and let's look at 12. If 4 over y equals 9 over 7, then 7y is 36, so y is 36 over 7. Okay, what can you conclude from the given? What can you conclude from given information? Alright, so do this. Let's just do odds for homework. And let's look at 14. 2 over 5 is y over k. So 2 over 5 is z and k. So then z have to equal y. Okay? So this is kind of similar. Okay? Because these have to be equivalent, then if it's 2 over 5 and 2 over 5 when they're then this is k, then this have to be equal to y to make these equivalent, right? Okay. And 16, explain why a over b equals c over d, b over a equals d over c equivalent. This justifies the property 1c on page 245. Which one's 1c? Alright. Well, this one's easy. You just cross multiply. So you get the AD is CB, and here you cross multiply and then you get AD equals CB. Right? And if they are equal in cross multiplication, then these are equivalent. So that's why you can flip the top and the bottom, and that's that one. The one see on page 244, 245 is that you can flip the top and the bottom, and it's just still equivalent. Okay, I think we are done. Let me just see. Yeah, this is exercise. So look at all this. There's no geometry in here. You see, it's all kind of pre-algebra stuff. This is a little bit of geometry. It's all manipulating proportions, really. No geometry. All right, so some of you should like this. Clearly, there's no proof in here. Okay.